Okay. Now, from the beginning, or since the beginning of this week, we have been talking about design patterns, and we understood in the beginning that we can have either we can come up with as a good design or a normal design, or it is so. In other words, just following or knowing the four fundamental principles of OO, the abstraction, encapsulation, inheritance, and polymorphism, is is not enough. We need to go beyond them to come up with good designs. And of course, we are interested in coming up with better designs. The packaging and the solid principles also help. And then we have the set of design patterns which have been developed, based on the industrial experience for solving reoccurring design issues. And we also learned that there are three categories of design patterns: the creational design patterns, the structural design patterns, and the behavioral ones. So far, we have been focusing on creational design patterns, and we have studied or learned the singleton design pattern, which basically allows you to enforce a behavior where you only want to create one object, one and only one object. On the contrary, or on the other side, you have something called factory design pattern, which allows you to go on and create a factory of related classes. You're able to go and create multiple objects out of them. And abstract factory just takes this concept to the next one, where you can actually have not only one group of group of classes, but in fact you can have multiple categories or groups, which we call them factory, and you can go on and create multiple objects for each factory. While the prototype is again a slightly different one, where basically it allows you to go on and says that rather than creating object using the new function every time, you can and going through the constructor, you can go on and you create object for the first time, and then use the clone function to make a copy of it. So today, inshallah, we'll focus on another one, which is the builder, and we'll go through this one, inshallah. Again, there are many others out there, but these are the ones which I believe are the most commonly used ones under the creational pattern category. So the builder pattern allows you to create complex objects using simple objects. Okay, so this is the whole idea behind it, that you want to go on and create objects which are built based on some simple objects. At the end of the day, in a builder design pattern, you have something called builder class, and this is the class which will be actually gonna go on and create the objects for you, or the final complex object for you. And of course, this builder class is independent of these other simple objects. So probably, when we're going to have a look at an example, it will become more clear. But at the moment, I just want you guys to know that, you will have simple objects you can use and combine these simple objects according to your business process or requirements, and create, more complex objects. And this design pattern is very suitable where you have such a scenario. So let's take a moment to look at this, class diagram we have in front of us. I'd like you guys to just take a moment to go through it, and then we'll discuss it, and then we'll look at what's happening inside this pattern. This is for example, an application you're developing for Burger King or McDonald's, and you're trying to automate their whole meal development process. Take a moment to read it, and then we'll discuss it together, inshallah. So anybody would like to comment on it? What's happening in this diagram? What's happening in this system?
It's like symbol packages, not packages, sorry, classes, and he keep extended to make it like complex, like for example item.
What exactly is happening here? What they are trying to do here?
It's like we start with a small thing and we are growing bigger.
Exactly. So as you know, so basically you have these small concrete classes, like very basic unit of chicken and veg burgers and
Yeah,
Pepsis and Cokes, and eventually you're gonna go on
and have a whole meal.
a whole meal. Exactly.
Doctor,
Yes, please.
I think the architect is trying to mimic how these objects work in real life, which makes it more intuitive for the system to work.
Yes.
So,
Yes, true. In other words, I believe what you're trying to say here is that more like, they are trying to reflect an actual business process there, right? In this case,
yes.
for example, making meals for McDonald's or Burger King. Right. So, as I said, the pattern again is a creational design pattern, right? So it's a creational design pattern. So we're trying to create objects, but we're trying to create objects using a builder class, which will basically allow us to create one final object, which of course will consist of these simple objects, right? And that's the whole idea. So in this case, we are actually trying to make meals. And of course, meals actually consist of, burgers and drinks, right? And their packaging. So let's look at a sample source code to understand what exactly is happening here, and then of course we'll open the floor again for our discussion on this design pattern. So first of all, they go on and implement interfaces, two interfaces, an item interface, which of course has a series of methods in it, and a packaging interface or a packing interface, which allows you to pack the drinks and the burger. So basically, we create these two as interfaces, right? And then we'll look at the next level. And in our next level, we have the burgers and the cold drink. And of course, these will also be implementing the wrappers in the bottle. So the wrappers, so basically, we create concrete classes that will go on and implement the packing interface. So in this case, the wrapper will implement the packing interface and also the bottle. While on the other hand, we created an important observation here. We created an abstract class for burger, which goes on and implements the interface. And we also created an abstract class called cold drink, and it goes on and implements the item. Now, in case of burger abstract class, they have something called packing. Of course, it allows you to pack new wrappers, and it has a price. Similarly, on the Coke side or the drink side, they have a new bottle because that's part of their packing, and of course, it has a price. And so basically, we know that they have been created as an interfaces, these two, and this has been created as an abstract class, a burger and cold drink, and of course, they go on and as part of their packaging create wrappers because burgers are wrapped and cold drinks are bottled. Next, we will have these concrete classes: burger, vegetable burger, the chicken burger, the Pepsi, and the Coke. And of course, they will be extending these abstract classes as happens here. So basically, the veg burger concrete class extends the burger abstract class, and of course, it will have its own price and a name in this case. Similarly, the chicken burger will have its own price, and you will have a name to it. And similarly, Coke We'll also go on and extend your Coke drink abstract class, and it will, of course, it has its own price and its own name. Similarly, you have your own price and your own name. Basically, again, just very quickly, interfaces. These are concrete classes which are implementing these interfaces, and you have abstract classes here. Burgers are being wrapped, cold drinks are being bottled, and similarly, then you have concrete classes for these abstract classes. So what we're left now is the meal and the meal builder. So let's see what's happening in a meal. We have an array, and we will add the items into the array. So basically, we go do what? In this meal, we go on and create a list of items, which is an array, and then we add items into that list. And of course, we can also get the price of that item, and we can return it, and so on and so forth. Because at the end of the day, the whole price will, because the meal will consist of multiple items, and hence you can get the price of multiple items, and you can go on and show them. And eventually, your actual builder class is this one, where you're actually going to create the meal object which you're looking for. And it will do what? It will go on and create this meal, which was this array of list of items. So basically, you're going to go and create a meal. And of course, if it's a vegetable meal, you will only add and create a new vegetable burger. And for example, in this case, the customer has selected the Coke drink. While on the other hand, for preparing a non-vegetable meal, again, you will create a new meal. So and you will have, as a result, you have created an array of items, and you're going to add an item, which is basically a new chicken burger, and you will add a new item. In this case, new Pepsi. Of course, you can always add new Coke as well. Doesn't matter. And this is your builder class. This is your main part of your builder design pattern, where actually you are responsible for creating these meal objects. And eventually, the demo class only needs to know the meal builder class, and they only need to focus on this one. And basically what they will do is they will say, oh, okay, meal builder. Let's create a new meal builder. And then what kind of meal you are trying to create? You are interested in creating a vegetable meal. So as a result, you will go on and, it will by default go on and create an array of items, and in that array of items you will have a vegetable burger and a certain drink. Similarly, in case of a non-vegetable meal, by default it will go on and create a list of items, and in there will you have a chicken burger plus some drink. And of course you can always get the total cost of it, which will be the cost of the burger plus the drink, cost of the burger plus the drink. So I just breezed through it very quickly here. Now the floor is open for us to discuss and exactly understand how this builder is working. Go ahead, guys. Let's have a bit of discussion on this together so that everybody understands this design pattern.
Doctor,
Yes.
the design have many number of classes. Will this will affect the performance by any means?
As I've been saying that once you start using design patterns, of course, the complexity of the system will increase. And as a result, like in this case, your number of classes probably will increase. And the question is what will happen to the performance. Now, the important point to understand here is that, maybe can't really make a comment on performance in a sense. Of course, you're still creating objects, but remember, you are creating objects here. Even in this case, yes, you have a lot of classes here, but when it comes to creation of object, and that's the strength of this builder design pattern, is that if you're interested in a vegetable meal, only a veg burger object will be created, right? While in the non-veg meals, you will only be chicken burger object will be created. And you need to have these objects anyway, because this is what the system is. So system is complex. You are giving as part of your business process or your requirements, you're telling them that you're allowed to go on and create multiple kind of meals, and each meal will have different kind of burgers, and they can have different kind of wrapping and different kind of classes and drinks. So hence the whole system is slightly more complicated. Hence. But the question here is that if I don't do this day and I don't come up with such a structure, then actually, if you try to control without such a structured way, it will be a nightmare to even, go on and make changes, update them, maintain and track issues or bugs in your system, and so on and so forth. So it's quite well structured. From a demo class perspective, you're only concerned with this one because this is what you're trying to do, and let it handle under the hood the rest of the parts.
I see. Doctor, can I ask another question?
Yeah, please go ahead.
Can we use enum in this situation?
Turki, can you repeat that one again, please?
Can we use enum classes in this situation?
The inner classes?
Enum
classes. What will be the benefit of that one?
we will have a set of fixed options.
Set of fixed options. Yes. Maybe in this specific example, one can argue, right? In this specific example, but remember, tomorrow, for example, they come up with a new meal, for example, right? Of course, you will have to go on and extend it. It's a bit easy to extend in this way. So, for example, if they come up with like a beef burger, right, like a Whopper meal, for example, and then of course they can add a new type of a non-veg meal, for example, right? So it's more structured, and hence as a result, it's more manageable.
I see. Thank you.
Welcome. So let's go back and dissect this design pattern one more time together. Let's start from this side now. What is the complex object you're trying to create? Because in this system, eventually everything will be consist of burgers, and drinks. But actually, as a business process, you're developing this application for McDonald's, like a touch screen, and I'm pretty sure you guys must have seen this touch screen nowadays in most of the McDonald's, where you can just go in and create and compose your own meals. Correct? Have you seen that one, right?
Yes.
Right.
So a lot.
Yeah, a lot is very common now. So basically, you're gonna go and your options are that you want to create objects at the end of the day for these two categories, right? So hence, you want the builder demo class to basically just know this and say what kind of meal you want to create. And in this case, for example, he's interested in a vegetable meal, and it will go on and create a meal, and basically it will consist of have a number of items, and basically you're going to add items. And this time around, because based on your business rule that if you're creating a vegetable meal, you have to add a vegetable burger, and of course one of the drinks. And that's exactly what was happening here, that if you're preparing a veg meal, you will add an item, but this time around you specifically only add a vegetable burger, and in the case of non-veg, you will add a chicken burger. So you are creating object here, a complex object, which is basically built up of simple objects. That's exactly what we said there earlier, that builder object design pattern allows you to create complex objects using simple objects. And that's exactly here. Is the design pattern clear? This specific design pattern is clear to everyone?
Yes.
Great. Now maybe I can ask a follow-up on this now, right? And probably, just to clarify one more thing, and I had a very interesting discussion yesterday with some of our students on this concept, not from this context perspective, but in general, and hopefully that will make sense here as well. In this specific example, I'm going to just use this word. In this specific example, they created interface item as an interface, right? While they created burger as an abstract class, what could be the reason behind it?
They follow the dependency inversion principle, I think. The high-level component should not depend on the low-level component. They should both depend on the abstraction, which is the item class here.
Exactly. So they are following that, definitely. But why why they created, or as a designer, and this is like a question as a designer, like why I will create this as an interface while I'll create burger as an abstract class? What could be the rationale behind it?
I believe because the item does not have attributes and the burger have attributes. So we make the item because it doesn't have attributes interface, and the burger because it have attributes and so on. We make it abstract.
Maybe also maybe the burger would have some functionalities that implemented inside it. So the vegan burger and chicken burger could.
Yeah, like a cost.
Yes.
Anybody else would like to make a comment on this? Like, why not make item burger an interface? Or why not make item an abstract class? You guys are touching on the concept anyway. I'm asking this again just to have a food for thought question.
Doctor?
Yes, Abdullah.
I think because the burger has attributes, so making it an interface would not let us be able to store attributes in it. And likewise, in the item, we can use abstract class. There is no problem, but it's meaningless because it will not add anything else. We don't have attributes to add in the item.
Correct.
No. So we have to use interface. It's better.
Exactly. Okay. Anybody else would like to make a comment on this point and share his thought? Let me check the chat as well. We want to enforce all items to have some attributes, and the burger has to be a class because we want to make objects of them. Okay. Yes, yeah. Yes, go ahead, please.
I think because burger class use another class, so we cannot make it an interface since it is use another class. So there must be a concrete method there.
Okay. Now let me make a comment on this. First of all, what we usually do is that when it comes to interfaces, we are, interested in a situation where usually you're trying to group unrelated classes. Okay, so you're trying, or let me start with the abstract class. Usually you use abstract class when you have some implementation to begin with, as you guys have been saying, like you have some attribute, some functionality. So you have some implementation to begin with, which is common among the related concrete classes. Right? So in this case, for example, the vegetable burger and the chicken burger are both burgers, right? So hence these concrete classes are related classes. And they happen to have some implementation which is common among them as well. And plus you happen to have, for example, an abstract method cost or whatever, which you want them to have their own implementation. But yet they are both together, they are both related. These concrete classes are related and they have some functionality here as well. So you tend to use abstract class in that scenario. Is this point clear?
Yes.
This is the first thing to understand. Second is, usually you use items when you are trying to group unrelated items or classes or group of classes. Like for example, item consists of burgers and cold drinks. Yes, they are items, but they are yet two different things, right? And hence they don't have any shared implementation as well. You're just putting a certain rule on it that both needs to be packed and both needs to have a price, but their packing is completely different, for example, right? So basically, you're grouping the classes which are unrelated to each other, and they don't really have any implementation. But you're only forcing a certain kind of behavior that you want both of them to have. So in those scenarios, you tend to use interface. And of course, one can argue with me and say, why not we just use normal inheritance in this case? Why?
I think because then I won't force them to use just Pepsi and Coke. They will use cold drink.
Which one will use, please?
Cold drink.
Yeah, who will use
Like we'll
it?
use the builder
The
button
builder,
beam.
yes. In other words, I think what you're trying to say is that if I use a normal inheritance, then he can go on and create an object of this one, right?
Yes, yes, absolutely.
Yeah, right. While in reality and the context of this whole system, there is no such thing as a cold drink, right? Either
Yes.
it's a Pepsi or a Coke. Or similarly, there is no such thing as a burger. Either it's a vegetable burger or a chicken burger. So basically, the moment you create an abstract class, of course, now you're saying that, you cannot create an object of it. Or it doesn't make sense in having an object in this case.
Doctor,
Yes.
if you want to add like another class, for example, a game for Happy Meal or something like that.
Yes. Yes. Yes.
So do we necessarily have to put it like with an extension, with a certain extension, or only a game would be enough? Like the same with the burger, you have a chicken burger and vegan burger. The games also, there is a different type of games. So would you have only one class of games, or I could do it depending on what types of games I have?
Mhm. So, for example, let's say you want to have, say, a toy here now, right? Which is usually part of a Happy Meal, for example, right? Or a kids meal, for example, right?
Yes.
And now the question is, do you have multiple kind of toys? And probably the answer is yes, right? That you will have multiple kind of toys. Now, probably toy again in this case, the way we are visualizing here, toy probably will not make sense as an object in this Happy Meal. Either it's like I don't know what kind of toys nowadays they're giving to kids, but some kind of a Superman or a or a Batman or something like this, right?
Because the toys, like in general and real life, it's changeable. Like it's changed every
Exactly.
period, every time,
Every
everything.
period they change, they come up with a
So would we like
Superman.
change the classes or
No, no, there we will probably, this is the whole strength of it. That here you will have an Happy Meal here. You will be adding items, right? But at the time of adding an item, so for example, if they change a toy here now, for example, from a Superman to a Batman, right? They will create it, and when they're adding here, they will change it, and that's it. The structure still remains same because they can. So the benefit here is that tomorrow, maybe 6 months down the track, the McDonald decides to bring back Superman again, right?
yes,
Because they thought Superman was very popular, right? This is a
yes.
very typical marketing strategy they use. That something becomes very popular after 4 months, 6 months, they bring it back.
But do I have like if they like think that they have to put a new game or new toy that's not, so I have to put a new class?
Yeah, if this, for example, a new toy comes in, like I don't know what could be another example, but some new toy, for example, right? Yes, then you have to, because this is the strength of your model, then that you can go on and easily create it and extend it, and khalas, that's it.
Yes.
That's the
I see.
strength. That's the strength of the structure. That's the strength of your design.
I see. I see. Oh,
So see how flexible this becomes, that you have a Happy Meal. So basically, you're only managing here, and you're making small changes here, and you're adding it here, and that's it. You don't really have to go on and worry about anything else, right? Say, for example, in this Happy Meal, for example, you can go on and have a cold drink, which is because for kids, you don't want to give them, say, for example, Pepsi or Coke. You want to give them some kind of a juice. So it's very extendable and it's very flexible. And the whole idea is you're creating objects. From a demo class perspective, he's only concerned with meat builder, and that's it.
Also, if for example, like the restaurant offer cold drinks as well as hot drinks, is it better to put a cold drink and hot drink as like separate classes, or make a drink, then we take subclasses that either cold or hot extend classes, Pepsi, Cola, coffee, for example, tea?
I understand your question. Now, the answer to this is not simple in a sense, because we'll have to look at the requirement of the system, right?
So okay, yes, I get.
Yeah, so we'll have to look at the requirement of the system. But this what, and it's actually very nice that you asked this one, because this is what I was about to make a comment. Is that we are using this example to understand the concepts of the builder class here, right? Or a builder design pattern here, right? So the idea is that you should have a builder class which will allow you to create the objects from the simple ones. And how these other parts are structured, you have tools of inheritance, you have tools of abstract class, and you have tools of interfaces. You use them smartly to structure your applications, and you create meals accordingly. And hence, of course, it makes sense in your system that you got to have a drink, and you can have a cold drink and a hot drink, and you have further classifications, or you already to begin with have separate classifications. That will boil down to again to your solid principles at that level, right? But and it also doesn't mean that a builder design pattern needs to have an abstract class, for example, or needs to have an interface. No, it just depends on your application. Okay. But as we just discussed, there is a situation where you like to use abstract class, and there is a situation where you like to use interfaces. And you as a designer, you make a call there depending on the scenario. Again, as we just discussed, typically you use abstract classes where you have some implementation and you have related concrete classes. And yet you don't want to create an object of that type because it doesn't make sense to have an object of that type in your application. Like in this case, this doesn't, cold drink is not nothing, or a burger is nothing. It's either a vegetable burger or a chicken burger or a Pepsi or a Coke or a juice.
Yes.
Cool. Alhamdulillah. Everybody's comfortable with the design pattern? It seems to be the case. So let's wrap it up. So again, I think I should not be saying complex here. So basically, we use creational design patterns to create objects. They can be simple or complex. Of course, you guys know now that you have singleton, where exactly you're trying to create one object, you're enforcing that behavior. Of course, you have factory, where you have a related group of classes for which you want to create objects. While abstract factory allows you to have multiple factories in it, or multiple categories or families of these related classes to put together, and you want to create objects from one place. And a prototype was the one where you want to create objects for the first time, and then use the clonable option to create clones of it. And we just had a look at the builder one, which allows us to build complex objects using simple objects. Right. So with this, we are done with the creational design patterns. So what I will do here is, as I did earlier for the first section as well, I'll stop it here, and I'll open the floor for any questions you want to ask me, or you want me to quickly review for you for the exam tomorrow. And then inshallah we'll start with the structural ones, inshallah, in our next lecture. So let me stop the recording, and the floor is open for any questions.
Doctor?
Yes, go ahead.